let's continue looking at 2.2 PVA homework problems, 99 and 100. So now we're given S sub t in terms of meters. Negative 4.9 meters per second is acceleration due to gravity. V sub 0 again is initial velocity. S sub 0 is our initial position. A projectile is shot upward from the surface of the Earth. So the object is going to start off at 0. And initial velocity 120 meters per second. So this object is moving upward with an initial velocity of 120. So we can create our position function, replace V sub 0 with 0, replace S sub 0 with 120, and replace V sub 0 with 120, S sub 0 is 0. So we get negative 4.9 t squared plus 120 t plus 0, which is just going to be negative 4.9 t squared plus 120 t. What's the velocity after 5 and 10 seconds? So we know we have to work our way down to the velocity function. So from S of t we find S prime. S prime is also a notation for velocity function. We go through the power rule, which is bring down the 2 times negative 4.9 is negative 9.8 t. 120 t becomes 120, 0 is just 0. And now we can plug 5 into the velocity function to get 71, and plug 10 into the velocity function to find the velocity, which is 22 meters per second. Okay, number 100. To estimate the height of a building, a stone is dropped from the top of the building into a pool of water at ground level. The splash is seen 5 seconds after the stone is dropped. What's the height of the building? So we know the velocity, the stone is being dropped, so it's not being thrown, which means that we know the initial velocity is 0. And but we don't know how high the building is, so we don't know S sub 0. So right now we're just going to hold on to this variable S sub 0. But we know the velocity, so we can replace V sub 0 with 0. So our position function is negative 4.9 t squared plus S sub 0. So we need some more information here if we want to find S sub 0. Let's see. We know that the splash is going to occur when the stone hits the pool. And when the stone hits the pool, it's going to be it'll be at position 0, height of 0. So we know our final position is going to be 0, so I can replace S sub t with 0. And also we know that the splash is seen 5.6 seconds after the stone is dropped. So it's going to take 5.6 seconds for the stone to reach from the initial height of whatever height we're trying to look for. That's the height that's missing. For the stone to reach from this starting height to ending height of 0 5.6 seconds later. So if I replace t with 5.6, S sub t with 0, then the only variable that's left is the starting position, which I'm looking for. So if we solve this, negative 4.9 times 5.6 squared gives us negative 153.7. If I add that to both sides, it becomes positive. So our initial height for the height of the building is 1537 meters.